So thank you all. Good afternoon. Thanks for joining us to our higher performance building on the Central Coast, all electric construction part 1. My name is Itel Torres with 3C Ren, working out of Ventura County. As many of you are new to our trainings, I would like to begin with a bit of housekeeping and the 3C Ren overview to introduce you to our programs, and before handing it off to our wonderful instructors for today, Mike Horgan and Jennifer Rennick from Imbalance Greens Consulting, and as well to Michelle Zimney that will be helping moderate today's training. Feel free to raise your hand and type in questions in the chat. And just another note, AI continuing education units will be available for today's course, and we will be sending out a recording. Next slide, please. So 3C Ren, the Tri-County Regional Energy Network, is a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. Our purpose is to improve energy efficiency in our region by offering customized programs and services for all building professionals and households with industry training events, energy code compliance support, and free and discounted upgrades that reduce energy at our home. 3C Ren is funded by ratepayer dollars that we pay into our utility bills. We do offer three programs: Energy Code Connect, Building Performance Training, and Home Energy Savings. The Energy Code Connect serves all building professionals, including the public and private sectors. We offer Energy Code Coach, which is an over-the-phone, online, over-the-counter, and in-the-field service to help building professionals navigate the complex and ever-changing energy code. We offer trainings and regional forums, which we have one coming up, and I'll discuss a little bit further in detail at the end of this training. We have our building performance training program, which serves current and prospective building professionals, from designers to engineers to contractors and real estate professionals. We offer technical skills and soft skills, and our training today is part of this program. Next slide, please. Our home energy savings program is currently paused, most program activities due to COVID, but we are hoping to relaunch the program and offer free and discounted home upgrades like thermostats and heat pump water heaters. And we will be also launching a multifamily program. At the meantime, the home energy savings program is offering home energy saving toolkits that can be checked out in our partner libraries. Please be sure to check our website for more information on that. And without further ado, I'll just hand it off to Michelle to talk a little bit more about our learning objectives and introduce our instructors for today. Thank you so much.
Thanks, Itzal. Hi, everyone. My name is Michelle Zimney. I'm a senior sustainability consultant with Imbalance Green Consulting. Our staff is presenting the webinar today, Heat Pumps for Heating and Cooling, as part of our Higher Performance Building series in partnership with 3C Ren. We are offering AIA credits, and these are our learning objectives for today. I assume most of you are familiar with that, and if you do need credit, please do contact 3C Ren. They'll be handling that for you. A little bit of housekeeping. I will be moderating today and fielding questions via the chat. We do have time set aside at the end of the program to field questions for Q&A session, but I'll also be monitoring if there's something that seems a bit more urgent. I'll go ahead and interrupt our speakers to get that answer for you guys right away. Without further ado, I'll go ahead and introduce our speakers today. We have Jennifer Rennick, principal at Imbalance Green Consulting, licensed architect and certified energy analyst. The presenter is Mike Horgan, a licensed contractor in California, as well as a certified passive house designer. And with that, I'll hand it over to our speakers, Jen and Mike.
Thanks, Michelle. We're going to get right into it. We've got about 40 slides to get through in about an hour. We've been doing pretty well with this presentation. We do like to tell everyone that Jennifer and I we've been doing these things in practice in the field. So this isn't just hey, we read about this, this is a good idea. A lot of these everything that we're doing, that we're talking about here, are things that we're actually doing in the field. A lot of the photos will be from projects that we've either worked on or are currently building at the moment. So we'll go a little bit over who, what, where, why. This is kind of a broad spectrum of heat pumps for heating and cooling. We've kind of combined, we probably have 4 to 5 decades worth of info in this field, and we're going to condense it all into about 45 minutes. So we're going to do the best we can to give you guys as much information as we possibly can so you can carry it over to future conversations. We'll go over some of the how-tos, the how-not-tos, importantly, the how-not-tos, and we'll get into some of the science stuff behind it. We've broken this presentation down into 5 parts. We'll give a quick overview. We'll go over the various different types of heat pumps that are used for heating and cooling, and where they can be placed inside your projects, residential and commercial. We'll go over some of the considerations when installing these systems into your projects. We'll go over a few little nuances that are important to note that aren't always front and center when people talk about heat pumps. And lastly, at the end, we've got a few slides pertaining to cost and some of the talking points when considering these for your projects. So getting right into it, heat pumps do not make heat. So we're talking about electric systems. So we don't have gas. We're not firing up a burner and using methane to create heat that we then push into a house through a bunch of various means. Heat pumps capture heat. They capture existing heat that's already in the air. There's heat in everything. There's heat even in the air down to minus 50 degrees that can still be captured by the refrigerants that we use today. So we have 2 units. We have an indoor and an outdoor unit. And there's a line set running between these 2 units. And in that line set, there's refrigerant. And that refrigerant captures the heat that's in the existing air, and it moves that refrigerant across a system that contains 2 fan coils, and the pump pushes that air into our existing spaces. So we're not making heat, we're moving or capturing and transferring existing heat that's already in the air. So that's just scratching the surface of efficiency. We're using something that's already there to help us condition our spaces. There are a whole bunch of manufacturers pertaining to heating and cooling when it comes to heat pumps in the US. There are numerous installation companies across the Central Coast. There are a few up here in the SLO area who specialize in heat pumps, and they're actually talking to one of the owners the other day. They're seeing most of their work shift towards heat pump and shift away from gas systems. So there are full companies that you can hire to install these systems. Most of those companies will do all types of the installations, the various different distribution methods. There are also DIY kits that you can buy. I've seen a little uptick in people buying the DIY kits around SLO. People doing their own ADU projects, really trying to conserve funds. I've seen them buy the DIY kits, and then I've seen them run into a little bit of trouble because lines have to be cut, and there are special tools that have to be used once the lines are cut. So the DIY kits, as simple as they may seem, there are some nuances that are involved in those. We're not going to get into that today, but you can email us and ask us if you're thinking about doing DIY kit, but they are available, which kind of hints to how easy these things are. Like they're pretty basic systems. If they're selling them off the shelf at Home Depot as a DIY kit, it's got to be fairly simple for non-tradespeople to be installing them. So there are various sizes and different installation options. There are generally 2 main options. We have ductless systems, which is kind of what I prefer to install in projects if I have the opportunity. And there are also ducted systems, and there are kind of 2 kinds of ducted systems. One of them is almost like a hybrid, and it's a little nuanced. So largely there are 2, ductless and ducted. Single zone, multi-zone, you can use numerous different types of indoor heads off of 1 or 2 outdoor heads depending on the size that you need. So you could have a 3-story apartment building and have 3 indoor units running off of 1 outdoor unit outside. And you could have 4 wall-mounted units, we'll get into the different kinds, and then maybe 2 ceiling-mounted units also running off of the same outdoor system. 2 things to really take note of. You cannot have heating and cooling at the same time, but these systems do provide heating and cooling. I think, Jennifer, correct me if I'm wrong, but they're coming close to having systems that can provide heating and cooling at the same time. I think it's in the works, but not readily available yet.
Yeah, for the systems we're going to talk about today, these smaller scale systems, it's what Mike said. You can set your system to auto, and it will figure out for you. The brains on board will figure out by looking at the different thermostats you have, if it's going to be in heating mode or cooling mode. And then you can move to more complicated commercial systems with variable refrigerant flow and heat recovery that is much more robust for like a big apartment building or something like that, or big office building where it will heat and cool at the same time. But that's because they have multiple branch boxes and systems in place. But for these more simple, straightforward systems that you'd see in small offices and residential units, it's just going to operate in heating or operate in cooling.
Yeah.
But like Mike said, it does both, which means you have one piece of equipment that does both things instead of like the traditional setup on the Central Coast, which would be you'd buy an air conditioner that's basically a heat pump but doesn't heat, and then you'd buy a furnace to do your heating. So now you're just going to buy the one unit that can do both. Yeah.
So getting into the first type of system, we'll start with what we call a ductless system. Again, you've got 2 parts. You've got an outdoor unit and indoor unit. So you've got an indoor unit, sometimes called the head, sometimes called the fan, sometimes called the supply, a bunch of different terms that get used. You have your outdoor unit, sometimes called a condenser, sometimes called a compressor, sometimes also called a fan. There is no universal, this is the exact right language to use, but there are 2 parts. I generally call it a condenser outside and a fan on the inside. But our installers might call it something totally different. So you've got a line set, which is two lines containing refrigerant. So it's a closed loop system, one going up, one coming back, going up, coming back. And then you'd have a condensate line, because in air conditioning mode, they will take condensate out of the air. It's just water. So it just needs to be drained into a drain, or it can be drained outside. A project I'm building right now, I'm draining it into a little bed that will be built in front of the wall. It's not very much water, so you're not talking about you're not going to flood anything. And then you have, the last thing you have is you've got a communications cord. So we usually call this a comm line. And when I'm in our office, I usually have one in my hand to show you, but these are probably like this combination of line set and communications lines, probably 3 inches, 2.5 inches, 3 inches in diameter. So it's a fairly small line. And you'd have the 2 line sets and your communication line, which is the black electrical cord that runs from the indoor unit to the outdoor unit. And we call it a comm line because it's talking to the 2 units. It's letting the 2 units work in unison. So.
Oh yeah, and that image on the right side, that's a picture that I took from an actual installation. And just to give you a sense of scale, since Mike doesn't have his prop today, like, you can hold that bundle in your hand really easy. And those little black lines going horizontal, those are just little regular zip ties. And then we'll show you, it's that size. It just is that size. And we'll show you a picture of what it looks like as they're kind of pulling it out of the box to give you a sense of the scale. It's fairly straightforward.
Yeah. So now that was a quick overview of the ductless. And again, this is like a few decades worth of info we're condensing into 45 minutes, but it actually is fairly simple. There's not a whole lot of nuances and differences to these things. So now we go to what would be called a ducted system, a fully ducted system. And you'd have an outdoor condenser, compressor, fan, call it what you'd like. Most people in the field will know exactly what you're talking about if you're talking about the outdoor unit. And you'd have an indoor air handler, not unlike what we'd have with the gas FAU system. It's basically the same setup, but you're not using fossil fuels, you're not using methane to create heat and move that heat throughout the building. But that's a fully ducted system. So you've got these design considerations because you've got to consider where are we softening down ceilings? Are we creating chases in our homes? Or do we have a closet where we're going to run ducts from first floor to second floor? It creates the same set of installation considerations as a gas FAU system. We talked about the two systems, the ductless and the ducted. This is an example. I think you can see my arrow. This is an example of a wall-mounted ducted mini split that I installed in a project that I built. This is on the coast of New England. This is on Cape Cod, so maybe a quarter mile from the ocean, if that, from the New England Ocean, so not our nice warm ocean here. And this is, I think this was a 1-ton wall-mounted mini split. This was a few years ago. And this is the only heating and cooling that we have in this entire house. And this was actually a 3-story new addition onto a 150-year-old cottage, and probably a total square footage of 2,500 square feet. And that's the only heating and cooling we used for the entire upper 2 floors. We did have another system downstairs, which I was reminded of when I saw a picture of last week. But it's fairly simple. That's it. That's all our heating and cooling for that entire main living area in this house. And then you have also a ceiling mounted ductless system. So that's a wall mount, that's a ceiling mount. This is what's called a between joist ceiling mount. So it's made to fit between 16 on center joists, with trusses, TJIs, whatever you're using. It comes with clips and you can attach it to 16 on center framing. They're fairly big. I feel like this picture doesn't do it justice. When I'm in the office, I actually have one I can hold up and you can see I'm 6'1" and it's not a lot smaller than I am in terms of length. So they're fairly large. I think I've got a picture of one from a project that we did across the street. This is a ceiling mounted system that we installed in the house right next door to me outside, actually. So you get a little bit of a scale idea of how big these are when they go into a ceiling. They're not unnoticeable. This is a wall mount in the same house right outside my window. In this particular room, fairly noticeable. We have a 3,000 square foot house we're building right now, and we have this installed already. Nobody notices where this is when they walk through the house. And usually we end up in a conversation of, well, where's your heating and cooling? And we have to point it out that it's actually mounted high up on a ceiling right above the front entry, and no one notices it. So, and we've got a 6,000 BTU system, pretty small for just under 2,600 square feet of conditioned floor area in that house. So pretty streamlined.
Mike, I'm going to just jump in here real quick. We do have some folks on the call that are not architects, and I'm guessing there might be folks that aren't familiar with BTU, tons, when talking about heating and cooling.
Sure.
Maybe if you could give some information about defining those terms and what a typical house that isn't built to higher performance standards might typically be spec'd with these days, and then what this new sort of equipment offers in terms of downsizing and efficiency.
Sure. I don't want to go too off track because we could talk about that for probably 20 minutes. But so BTUs, the acronym is a British thermal unit, and 1 BTU is equivalent. I mean, who knows why we still use this system, but 1 BTU is equivalent to the amount of heat given off by a match. One match being lit is 1 BTU. Why that's still the relevant system that we use today, I have no idea, but it's what we use and it's what we're sticking with. So a 6,000 BTU system, 12,000 BTUs equals 1 ton. So when we say a 1 ton system, that's a system that's providing 12,000 BTUs of heat into a building. So a 6,000 BTU, we call it a half ton system. 9,000 BTU, we call it a 3/4 ton system. That's kind of about as far as I can go. Jennifer, you want to add anything to that? But it's an archaic system, but it is what we do.
No, but I think when we look at the pictures and then we say, okay, this size of a piece of equipment goes to a house that's this big, that might help. But it is, if you're not in that trades, it does, yeah, we'll do our best. But hey, I want to point out that it's completely acceptable and welcome if you put your questions in the chat. And Michelle's going to be monitoring that chat, and I'm looking at that chat now as well. So if there's a term or something or a specific question you have about your own project, or if you're coming at it as a planner or as someone in the trades or just as an interested homeowner, there no questions are bad questions. They're all good. We're all just learning about this, because even those of us who've been in this business for a while are still kind of realizing, like, for example, this piece of equipment that Mike's going to go into next, this is like a new piece of equipment for a lot of people who've even been doing this for a while. And they have crazy names like ductless, ducted, and stuff like that. So I'll let Mike go into it.
Michelle, importantly to the question that you asked, to finish that up though, so we kind of define what BTUs were. It's archaic, but it is what we use. But comparing, so when I say I've got a 6,000 BTU system in a 2,500, 2,600 square foot conditioned floor area house, you said compare what I'm talking about to a conventional home. We are talking about higher performance, generally all electric buildings. So our house, this one that gets referenced a lot, is built to the passive house standard. So it has a few nuances to make it a little more high performance. We've got 6,000 BTUs in we'll call it 2,500 square foot home. It just so happens there's a house being built around the corner, 200 or 300 yards down the hill, where we're just about on the same schedule. We're in the same phases, started excavation at the same time. You're not throwing anyone under the bus, like everybody does different things. It's about the same size house. I think it's a 2,700 square foot conditioned floor area, single level, just like ours, 2x4 truss ceiling. They have so I have a 5-ton heating and air conditioning in one unit on a wall mount system in our project. They have a 5-ton system in their house, and they have 2 different condensers outside, one for air conditioning and then one for heating and cooling. And they have all the ducts running underneath a crawl space. So they had to build up on a crawl space. And then the ducts run through closet spaces up into the attic space and then distribute throughout the house. So that's 2 houses about the same size, one built to a higher performance standard, one built to a code minimum. I have a 6,000 BTU system in ours, and they have a 5-ton, so a 60,000 BTU system in that house. And it's just about the same size house and just about the same construction schedule.
I think that's a helpful comparison to make. I just wanted to let you guys point that out.
Thanks.
Thank you guys. Jump right back in.
Okay. All right. So a little off track, but that's an important track to go on, actually. So we talked about the ductless system. I prefer those for a bunch of reasons. There's also what we call we talked about the ducted, which is a forced air system. And then there's also what we call a concealed duct system, sometimes called a ducted ductless system. We call it a ducted system because it has short runs of ducts. It's not like you have a full FAU system where you're creating chases or you're using attic space and you need room to get from first floor to second floor or from room to room and you've got to create a soffit around a wall. These generally work the same way a ductless system does. There's an outdoor unit and an indoor unit, and there's refrigerant lines running between the two. And then off of that indoor unit, you'd have shorter runs, maybe just a few feet, maybe 15, 20 feet. And the ends of those runs would have registers dropping down into a wall or into a ceiling. So it looks a lot like a forced air system, but you're not forcing, you don't have ducts forcing air throughout your entire house. We've touched on the ducted system. It's basically not unlike a gas FAU system. You'd have an air handler inside and then larger ducts running throughout your entire project through soffits or through chases. Okay, installation considerations. Jennifer is going to take it from here for a little while and I will step off into the background.
But not too far into the background.
Yeah.
Okay, I want to give you guys an image of what it might look like in a retrofit or new construction, but this is an example of a retrofit of delivery and kind of the setup for a ductless heat pump system. And your line set comes coiled up in big cardboard boxes. The indoor units themselves are nicely packaged up in another box. The outdoor unit can set on something as simple as a pre-made fiberglass pad. And that outdoor unit comes nice and packaged up, and then your guys who are installing it are going to have a big spool of the electrical communication wire. And then while someone's unpacking these bags, you've got another guy who's going to take either zip ties or electrical tape, and they're going to tape together these line sets that hold the refrigerant and that communication line and start bundling it together and making a long coil and getting ready to connect the outdoor unit and the indoor unit together. And when it comes to the outdoor unit and what you could do for mounting, and this really comes, homeowners, okay, keep it in mind, but if you're an architect, engineer, you're thinking about really incorporating this into your practice, there's a lot of options. It could be a really small pre-made fiberglass pad, because these units are pretty lightweight. You can set that pad on stable ground, bolt it to the fiberglass pad. You can also mount it to the walls with specialized wall mount racks, and those wall mount racks are easily purchased and made for the purpose. And then if you live in snow country, or if the ground really isn't in a situation where you want it on the ground, you can pour a concrete pad and mount it to that, or you could put it on a snow rack. And again, those are specialized racks meant for keeping your equipment out of the snow. And this is what that looks like installed. And most of these pictures are from our projects, with the exception of the snow rack one. That one I had to lift from the internet. But all the other three projects are for our project. So you can put it in the fiberglass pad and blend it into the stonework of a landscape, or if you've got a concrete patio outside already, you can mount it to that. And if the soil isn't stable, you can put it up on a wall rack. So they're very flexible in how they can be installed. And this picture shows Mike. Okay, he's going to tell you, this is a total poser picture for marketing, right? But this installing it, and I'll let him tell you. But
it's a real photo. Yeah. It's a real project. But we did need to. It was used for a pamphlet for a workshop we were doing with the city of SLO, and they needed a photo of someone installing a system. So I am posing, but this is actually how we do it in real time. It's fairly simple. These racks, you can order these racks off Amazon. You can get them at miners. and they simply just bolt into place. The little feet on the bottom of the units just get bolted down. And the reason we did it here was, this is a project, friends of mine who installed one, and they wanted it hidden off to the side yard, but the side yard also contains their drainage path. So we didn't want to put it on the ground just for fear of water kind of pooling up in this area. So we simply bought a rack online and mounted it to their wall. You can see it got mounted in the wrong spot the first time, and it got patched up afterwards. So this is kind of a homeowner DIY. Had a lot of hands in this, but that's it. Just a simple wall mounted rack.
Yeah, it worked out great. And something to keep in mind when you're choosing the location for these outdoor units, whether it's new construction or remodel retrofit, the outdoor unit, you'll notice like in that previous photo, the unit sits away from the wall. So you do need clearance between the unit and the wall for the air circulation around that outdoor condensing unit. You also need to make sure you don't have too many obstacles in front of it, so that 3 foot is recommended of clear space. Don't put a wall any closer than 3 feet in front of the unit. So again, the air can circulate freely. And super, super important, this is a code issue, but we do see that it's sometimes forgotten about. And the code on purpose says you can't put these outdoor units any closer than 5 feet to dryer vents. And Michael point out, if you go with specialized dryers, like heat pump dryers that don't have outdoor dryer vents, it's not a problem. But especially in retrofit situations, your clients might already have a dryer that's vented. And so you're gonna wanna make sure these outdoor units are at least 5 feet away from that. And then there's a little bit of clearance space you need on the indoor unit. Now, when it comes to placing these and sort of optimizing your placement, you're gonna wanna find a location outside where the unit's protected. They're not terribly noisy. I have one in my backyard, and it sounds like a refrigerator outdoors. It's much quieter than my neighbor's air conditioning system, for sure. I can still hear the birds in the morning over the sound of the heat pump. But if you don't want to see it, put it someplace where you can get it out of the way. And then you've got about 50 to 65 feet of run between that outdoor unit and your indoor units. So it gives you effective length of like 100 feet that you can work with. Anything you want to add to that, Mike? I think
No.
it's covered. Okay.
Yeah, I think that's pretty good. The effective lengths seem to be getting longer and longer as design progresses on these. And I say that, and I don't want to scare people to think, oh, well, so they're new and they're developing. Heat pumps have been around for decades and decades now. They're utilized the world over. Australia, New Zealand, China, all places I've lived, it's kind of the only system that they have. They don't use gas the same way that we do here. And a lot of people kind of look at it funnily when they do hear that we use gas the way that we do here and don't utilize such a simple system. So they've been around forever, but everything changes. Every day is a school day. So the line lengths are always getting longer and longer.
Yeah, that's right. And so this is an example of that outdoor unit being set in a retrofit situation. So in new construction, you can put the line set in the wall or hide it so you don't see it. In retrofit situation, they make specialized metal and plastic covers, I guess you would call them. There's a part of the cover that mounts to the wall directly, and then a portion of it, and then another piece that clips over the top of it so that the whole thing is really quite clean and set up. You'll have to have an electrician come out and make sure there's a dedicated circuit. And then they're gonna set their indoor units and basically put a small hole, about a 3-inch diameter hole from the indoor unit through your wall with that line set that comes off the indoor unit and the communication wire. And then they have then they're going to bend it down and connect it up to the rest of the refrigerant line that goes into the outdoor unit. No, that's perfect.
Okay.
And so what this looks like, that indoor unit, you know, kind of the backside of it, when you get it out of the box, all the parts and pieces are neatly packed in there. So that's that same gray line set we saw in the previous picture that gets kind of opened up and pulled out and pushed through a hole. And it comes with a specialized wall bracket that your installer can set up and put the hole in the right spot and hang that unit up on the wall and get the electric and everything set up for it. And that's what it looks like before the filters go into place, just kind of under the hood. That little lid closes and then it has a real clean look, you know, on the outside once it's closed. And then for the indoor unit itself, the airflow is going to come in through the top and then be pushed out through the bottom, and it's louvered.
This might be a good chance to say, when we keep talking about this line set connecting an indoor and outdoor, you know, this part here on the inside is this part here leading to the outside, which then leads down. If it's a retrofit, it's probably outside the building. If it's a new construction, it's inside. And then that's it connecting to the outdoor unit. So that's the whole system.
Yes, that's right. And so it's fairly straightforward. And so that particular project, it took under 3 hours to install 3 indoor units and the outdoor unit. And Mike, we had another client we'll show you a picture of, same thing. It took only a few hours. We almost missed the job. Like, we called them up, we were running late, and they go, oh yeah, we're just finishing. What? So they show up at 9, they're done at noon. I mean, it's really pretty straightforward, which is nice. Another option for some of our clients, I'm going to show you this, is the indoor unit, also ductless, but it can be recessed into the ceiling. And the way that works is it pulls the air from inside your room kind of up through the middle of the unit, and then it pushes it out on sort of the louvers on the outside edges. And you can even set it up to have what's called throw, and it can be 4-way throw, so air comes out all 4 sides, or 2-way or 3-way. You can fine tune that. And this gives you, you know, 9 to 12 inches deep, depending on the size. So it fits within your kind of ceiling cavity usually. And then the whole unit, again, depending on how big you need, it can be 22 inches wide, even up to 33 inches wide. So they can be quite large on the commercial projects. Most of our residential projects, they're around 22 inches wide. So you can imagine almost a 2-foot by 2-foot square up in your ceiling. So for some of our clients, it's a bit big. For other clients, they just think it's great because they don't want anything mounted on their walls. They'd rather have it just up in the ceiling. This is another installation that is pretty popular for some of our clients, where this is that ducted, ductless unit, which can be set up to have the ducts like Mike showed in that one photo with the big silvery insulated ducts coming off, or it can be set up to be really more ductless style. So it goes into a soffitted portion of your ceiling. So in this photo from Mitsubishi, there's the fireplace, and then above it, they made a soffit and they put the unit there. And the grill in the back lets the air come into the unit. And then the grill in the front is where the air is pushed out. And it's that grill also doubles as a way to get in there and change the filters as you need to. So this is another job we worked on where same kind of unit, only this time we put a lot more duct work on it. So now we're calling it a concealed duct system, or the ducted ductless, or the partially ducted. You're going to hear all different kind of names for that. And this case, we didn't mount this or hang it from the roof rafters or the ceiling. We put it up on supports with a drain pan. And Mike mentioned that all these units have condensate, but it's just, we'll mention that in just a second, give you an idea of it. But I want you to know that each of these units have a built-in pump that takes that extra condensate out of the system. So, but just in case there's any leakage, it's good to have it in a drain pan. And then the front and the back of the units are ducted. So what this might look like in kind of section is you might have a return. That means where the air goes into the system and it's pulled up. And in this case, with this actual, system, as it comes up and it sort of loops around, it goes into there, it gets heat, that air gets heated up even more, and then it's pushed back into the room as the supply. And those refrigerant lines go back and forth between the outdoor unit and the indoor unit. And they can be installed in attics, or they can be installed like in a knee wall where you've got maybe a cathedral space on one side. So in this case, the return is pulled up and the duct loops around through the unit to the back, gets heated up, and then the air is pushed out through the supply into the bigger space.
And this is a chance here to say that, we've talked a little bit about the fan coils. We've got refrigerant moving in between two sets of fans, essentially. So you'd have a fan coil in here and another fan coil in here. And this refrigerant is what's moving. The refrigerant's capturing heat from the air outside, running through the lines, moving up into this fan coil here. And our air is coming in through this return, through a duct, and then being pumped across that fan coil and warming up. And that's where you're getting your warm air from.
Yeah, that's right. And kind of a variation on the ducted ceiling. This is one where we see this in like apartments and multifamily projects a little more, where they might put a big return grill, which also doubles as the access panel to that indoor unit. And then it has a very short duct in the front of the unit that pushes the supply. And so in this particular project, from the kitchen side of things, it just looks like a recessed, like ducted system right there. And in the hallway, it just looks like a really big return. But this is where maintenance, they can drop that whole grill down and get to the fan, get to it if it needs maintenance, periodically change the air filters on it. There's a few additional considerations. And then speaking of air filters, okay, so this is what these units kind of look like under the hood. And there are really thin filters. They look a lot like the same filters you might see on your dryers, for those that have the ones that slide in and slide out, and it's the light plastic with the light mesh on it. It's very, very similar. Okay, that top one was filled with dust, and okay, truth be told, that one's from my house, because after COVID, I had 3 cats, a dog, and both my kids and I all in the house 24/7, and it filled up with dust faster than I realized. So when I noticed everything wasn't working too well, I was like, okay, what's going on here? And I lifted that lid up and I was like, oh my gosh, okay, I need to change it every couple months, or every 6 weeks when we're all living here. But otherwise, normally, maybe if you're gone a lot and this is at home, you could change it like every 3 months. But when you change it, you basically pull these things out and you vacuum it off, or you run it underwater. You clean it off really, really simply, just like you do with the dryer vent. And so it takes me like 10 minutes, and these things I clean all of them for the whole house, and then everything works really good again, and the efficiency goes back up. One thing I want to mention, Now, if you're a designer and you're designing the system for your clients, it is good to put these units somewhere where that drain line, that condensate, can get to the outside of the building. It makes things a lot easier for the guys installing it, and then they're not going to change the location from your current design. If you're a homeowner or you're thinking about putting these in your house, again, especially retrofit, it's much easier to mount these on outside walls because of that condensate drain line. And I want to point out that that condensate is just the same kind of dew, the same water that collects on the outside of a cold drink. It is just moisture from the air. It's perfectly clean. It's like distilled water. In fact, it is distilled water. So there's nothing in it that can cause any damage. It's very different than the kind of condensate you have to deal with on gas appliances. It's just water. So keep that in mind. Now, the other thing you might not realize, or quite, we kind of see that some folks don't quite realize that the indoor unit is taking air from inside your house, the air that's already there, and it's pulling it through this fan coil, and it's heating it up and then pushing that same air back into the space. And on the outside, it's taking air from the outside, pulling it through the unit, outdoor unit, and pushing it back to the outside. So in order to get fresh air, you have to include another system to bring in outside fresh air. Code says you can use an exhaust only system, but when you pull air from inside your house and kick it outside of your house, then you have to make up the difference. And that relies on what we call a leaking envelope, which basically means air from outside is forced through the cracks of your house to make up for the difference on the exhaust fan. It's code compliant, but not that energy efficient. So we recommend going with a balanced ventilation, which means you'd have a supply fan added to the system, and it's going to push and filter the air with a filter. You're going to now have filtered fresh air come in the same amount that your exhaust fan takes out. So no longer depends on a leaky envelope. But in some cases, this could introduce too much cold air to a space when you're really trying to conserve energy. So even better yet, as we'd introduce what's called heat recovery ventilation. And basically you install one unit or pairs of units that allow the incoming air to be warmed up as it's coming into the house. So you don't just dump cold air into the house. And it's still balanced because this same amount of air leaving the house matches the amount of air coming into the house. And so this design also works with that tight envelope, meaning an envelope, meaning your walls, windows, floor, roof doesn't leak air through all the cracks. This is energy code compliant, and in some cases even gives extra credit on those energy calculations that you do for building permit. Now, Mike's on the next slide, Mike's going to show you what some of those systems actually look like. And so what we usually do is we have those heat pump systems for heating and cooling like we showed you, and then that system is coupled with one of these products for the fresh outside air balanced ventilation that does the heat recovery.
Yeah, and it's really important to state, and we've had questions about this and maybe even a little confusion about it before, that these heat pump systems, they're not providing ventilation to the house. They're not introducing fresh air. They're recirculating the air that's inside the home. You know, you've got this line set with refrigerant heating up the fan coils, and this is pulling air from inside the house over that fan coil and putting it back in the house. So it's recirculating your air. So the ventilation system is a separate system. This is a Zender system that I've installed in what we call a high performance home. Through my tool belt on the ground there, just to give you a little bit of scale of how big that system is. one person can pick it up. We mount it on the, in this case, we mounted it in the garage. You can mount it in a mechanical room, but people put them everywhere. Very quiet, just a continuously running 2-amp draw. So very low energy use and very high efficiency. And all it is a system of ducts running through the house, and there are supplies to the living areas and exhausts from where you have staler air, like powder rooms, laundry rooms, or mud rooms, or even walk-in closets. These are all the tools that I needed to install that entire system. Just stacked them up on top of a Festool roller and rolled around the house with 2 drill bits, and mounted all the ducts with a little bit of UL tape as well. So that's a ducted system. There are some localized systems, Panasonic, and is it Braun? I think it makes also a localized system as well. These are a
Yes.
little larger, but they are recessed into the ceilings and provide balanced exhaust and supply ventilation as well. This is what's called a Lunos system. There's a Lunos heat recovery, HRV heat recovery ventilation system. This system works in pairs, really good for smaller spaces, say apartments or ADUs. One pair can provide the ventilation for about a 1,500 square foot building or apartment house. 1,500 square feet is more than enough for a house. You'd have one unit pulling air from outside into the building, and then at the other end of the building, you'd have another unit exhausting that air. It's just moving fresh air across the building, and then they switch. They're wired together and they switch. The other one will pull air in and the other one will exhaust. So there are numerous systems available, readily available, for us to get balanced ventilation with heat recovery into our projects now. Real quick, everyone loves to talk about costs. It's pretty simple, only a couple slides on it. I like to talk about costs, and I think costs should be talked about in terms of percentage of our overall construction budgets. If you're an architect or a builder in the room here, we all know that pricing a home or a construction project by square foot is probably the worst way to do it. Very few of us would look at a project and say, okay, I built everything at 300 a square foot. It's just not the way it works. But yet we still resort to that when we're talking about, averages. So if we were to look at, is a heat pump system more expensive than a gas ducted system? Well, it's not an apples to apples comparison. It's kind of like an apples to elephants comparison. There are so many other things involved in choosing what system you're going to use. Those things need to be brought into the equation and into the conversation as well. We're talking about building higher performance homes. So these are homes that work within a system. It shouldn't even really be higher performance. It should just be what we're building. Our home should be thought of as a system the same way we think of our cars. So if I look at the total percentage of construction costs for a wall-mounted ductless system in a 3,000 square foot home, 2,500 square feet of conditioned floor area, that's the slice of the pie that it takes up for my overall construction project. I referenced 2 homes earlier in the conversation, the higher performance home we're building, and then the other one that's a few hundred yards away from our house. I know that our 6,000 BTU, so a half-ton BTU wall-mounted mini split that provides heating and air conditioning to this home that we're building cost us, it would have been $3,600, and then COVID hit, and the cost of construction have skyrocketed over the last year. So it was about $4,400 installed. That's heating and air conditioning, and it took all of 3 hours for the whole installation to be completed. It's a really tiny slice of my construction project. I know that other house that's installing a 5-ton system, that's probably running them $35,000, $40,000 for all of their heating and air conditioning inside that house. Now, I don't have gas run to this project, so I've saved 11 grand on not running a gas line to my system. That more than covered our entire PV installation on top of our garage roof, so a 3.6 kW PV system as well. So we're about 4,400 into our wall-mounted mini split, and we're about 9 grand into our entire Zender fresh air with heat recovery system. So we're bringing balanced ventilation into this house for about 9-10 grand totally installed, and 4,400 for our heating and air conditioning installed into this project. So do the math and you can see which one comes out on top fairly quickly. These are very rough numbers that are just a conversation starter. Every project will be different. Every home build is different. Every design is different. If it's a renovation, it's a whole different ball of wax. Figure 35 to 400 for a 9,000 BTU ductless indoor wall mounted system. So that's about where we are in our project with a 6,000 BTU system. Add 1,200 for a ductless ceiling mount. That was the square one that mounts into a ceiling, or the between joists systems that we talked about. They're a little bit bigger, a little more intricate. They might sometimes require a little bit more work on the back end of things too. But the idea is to, build a home that doesn't need 4 or 5 separate zones. Build a home that needs one zone, and then uses an air supply system, a fresh air exchange with heat recovery to move that air around the home. So we have a central supply of heating and air conditioning in our home, and then we use a ventilation system, fresh air, filtered fresh air with heat recovery to move that conditioned air around the home. We don't anticipate it'll actually ever even be turned on, but it's installed in the house. So if you jump up to a 12,000 BTU, which would be a 1-ton system, bump up your price by about $500. If you go from a 15,000 BTU to an 18,000 BTU, so a 1.5 tons, add 1,800, probably add 2 grand to be safe. A concealed duct system. So this is the one that Jennifer was showing, where you'd have registers that don't look unlike our normal gas FAU systems that we're familiar with. 1,500 square foot home with 3 zones, independent controls for each zone. Figure about 20 grand. Probably a little higher today, given the way prices are rising on the daily. A fully ducted system for a 1,500 square foot house, figure 12 to 15 grand. Since we put this together, probably closer to 20, just the way everything's rising right now. So that's a very rough discussion on costs. It's important to point out that it's not an apples to apples comparison. It is an apples to elephants and zebras comparison. You need to look at the whole factor, the cohesiveness of your entire project, and factor in those costs. You can't compare a Volkswagen to a BMW. They're both going to get you from A to B, but they are different systems. So that's about it. The broad overview.
Yeah, we have a couple of questions, I think, in the chat. I haven't read through everything, but I could kind of glance over and I see things happening over there. So I think Michelle might have some questions for us. And
thanks, Jen. I'm actually gonna hand it back to Itzel so that she can launch the survey, because people might want to leave right at 1, but we will be staying till 1:15 to field questions. And I have noted those about the filtration. That'll be the first on our list.
Yeah, thank you. Can you switch to the next slide, please? Mike, thank you. So I just wanted to provide you all with some closing announcements. If you could please take this poll that I'm about to launch. All feedback is extremely helpful for our team to help inform our trainings. Another quick note is, if you have any questions regarding AIA continuing education units, please feel free to email me directly. And just wanted to highlight with some of our upcoming courses, we have our part 2 for this series coming up 6/8, which the focus will be on heat pump water heaters and other electric appliances. And also wanted to highlight our forum coming up 6/15, that during this event, attendees will hear from public health of professionals and energy experts about harnessing the nexus between healthy indoor quality and building better buildings. So really interesting forum coming up. Hope to see more of you folks join that in. And with that being said, I'll hand that back to the Imbalance team for some questions, and I'll just put in some emails on our chat and our website link. Thank you so much.
Thank you, Itzel. And sorry to interrupt, Jen. We are ready to get into questions here. The first one did have to do with MERV filtration or just in general filtration on those heat recovery ventilation systems, especially when we have poor air quality in times of wildfires or otherwise. What do you say in terms of what's possible for HRV filtration?
Yeah, a lot of those units. Okay, so for example, the code complying Rhone balanced ventilation supply ventilation units. I did mention that they have, filtration. So those can be ordered with a MERV 13 filter. And when wildfire season hits, that's a good time to use that ventilation intermittently. Sometimes almost all the code complying exhaust only or balanced ventilation system has a way to temporarily turn it off. You should leave it running all the time, but sometimes for wildfires, you have to do that. And you can get better than MERV 13 filters, but you does require some specialized, you need a box to hold it, and you got to make sure you're not inducing too much static fan pressure. So you'll have to work with the manufacturer on that if you want to go higher than the MERV 13. Mike, what do you want to?
Zender makes a MERV 15 attachment for their systems. They come with a MERV 13, I believe.
And just for reference, everyone.
And so a lot of them come automatically MERV 8, but then you can get with the higher filter.
Yeah, generally speaking, a HEPA filter would be the equivalent of MERV 20. Is that right?
Yeah, that's basically right. And so if you want the higher filters, then work with your builder or installer, or if you're doing it yourself, call the manufacturer. Just make sure that you're getting the right parts and pieces, because sometimes those filters have a bigger depth, so they're not going to fit in the box unless you order it, or you might have to add a box to hold the filter, but it's possible to improve that. And I think I answered the MERV question. If I didn't get, let me know, or unmute yourself. I think we have a small enough group. I can't tell.
I think we're good. There's a bit of a delay between us, so we're having a hard time timing it, but I think you got it. On a different topic, wondering about those outdoor mounted units. Some folks are thinking that they don't look that great. Is there a way to cover them? I think we might know the answer, or otherwise just sort of obscure the look of them. What are your suggestions?
Yeah, you can't cover them. Yeah, we have such weird nuances around here. You can't cover them, but what I often do is you do want this, let's see, where is it? You don't want this clearance in front of the systems, which that means don't put it in front of a wall, but I generally put plants around them almost every time I install one. So I'll put it, closer to the house, and then put plantings all around it. So,
and the idea is those outdoor units are fans, right? And so they're sucking air. Sorry, Jen, go ahead.
No, I'm sorry too. Delay. I think we have a little delay. So yeah, sorry about that. I have seen some really interesting images coming more and more on the internet as I just sort of snoop around to see what other folks are doing and working on. And I've seen some great, creative horizontal screens that people have used. When I say screening, like they've taken, for a more contemporary look, they've taken Ipe boards, run horizontal with big gaps in it, and they've basically kept it 3 feet away from the unit and just screened it. Just put the unit, met all the clearances, and then put plants in front of it that way. And when I see those pictures and look at the house, you never even know they're there. So I think that's just part of the creative design.
Yeah, this is the unit. So it's not super ostentatious. It's just a part of a mechanical system outside the house. Figure the average size house we're building around, even what we'd consider a small, efficient home has got a 3,000 square foot footprint. It's pretty easy to hide that little box somewhere in those projects. So.
Yeah, and a lot of our projects, they have outdoor units that are twice this thickness, twice the size, just for their air conditioning unit that's mounted on a concrete pad somewhere. So these, considering that they're lightweight enough to be mounted on wall brackets or just a fiberglass pad that can be incorporated into the landscape, they're actually easier to have blend in than a typical air conditioner system.
All right, let's switch topics to retrofits. Question about issues and costs that come up in that situation. Can existing ductwork be used? Can an existing FAU fan be used for circulation from an interior head?
In theory, yes. In practice, you have to get you don't have to get them inspected, but you need to inspect the ducts to see what kind of condition they're in. If you've got 20, 25-year-old ducts, would you attach a brand new system to 20 or 25-year-old ducts? Probably not. One of those things is then going to fail before the other. So you'd probably be better off not utilizing the existing ductwork. Can in theory.
Yeah, it also depends on what your ductwork is made out of. If you have a building or house with actually has like sheet metal ducts, sheet metal ductwork, where you can go in and perhaps take off the exterior fiberglass insulation and inspect it for leakage, because I have been in projects where, yeah, it was great. They were sheet metal ducts, but they leaked like sieves, like 30% of the air was leaking out through all the metal knockout holes. So it kind of depends. And then if it's flex duct that's old, no, chances are you're not going to be able to reuse it because it tears and breaks so easy. But that same example of the retrofit house that I was showing you guys, that used to have a ducted system that ran under the floor. And when it was inspected and the condition, the holes, it was cheaper to just tear out all the ducts and clean everything up and go with a completely go with a ductless system than to replace the ducts and try and do a ducted system, including just replacing it with a new furnace because the heat exchanger was cracked. So it really depends on the situation. That one project where we showed you the concealed ducted up in the attic in those knee wall projects, that was a similar, that project, that was a similar situation. They had ducts running all over that attic and none of them could be reused. And what you can't really see in the picture, or maybe you can, Mike, if you kind of scroll your arrow on it, that return duct is just, it just loops right in front of the unit. So that length of duct work itself is very small. The length isn't very long and it's super well insulated and it's a very large diameter that doesn't exist on a lot of existing ductworks, and it makes the unit very quiet. And then the supply duct goes right from that unit and just outside the picture. You can't see it because my camera wasn't quite able to get enough. It just goes down into the unit. Again, by the time your guys buy that boot that connects to the unit and adds that little piece of duct at the register, there's like nothing left for them to want to reuse an existing duct system, really. So that's why, practically speaking, you're probably not going to end up reusing too much of it. from a practical perspective. But every project's different. Every project's different. So you just have to look. I hope that answered the question. So in this case, again, they took out those old ducts that were perforated and torn and kind of spaghettied all over the attic and really cleaned it up and better insulation, for the whole thing.
Yeah, that's helpful. Oh, I sound terrible. Echo. I think that was a really thorough answer. I'm waiting to see if there are any more questions that might come into the chat at this point. Some folks are leaving. And I did want to give folks an opportunity to either write in a question or go ahead and unmute yourself if you wanted to ask a question at this point. We've got just a few minutes left as people are winding down and getting back to their work days.
Michelle, I have a question.
Okay, Patrick, go ahead.
Yeah, are we going to have access to the slideshow and recording?
Itzel.
Yes, I will be sending out the recording via a follow-up email.
Okay, super.
Mhm.
Thank you. Hey,
Mhm.
great show, you guys.
Thanks.
Thanks. Thanks.
I'm going to go ahead and put our contact information in the chat. If you do think of some questions, after we hang up, Jennifer, Mike, or myself can be reached directly. It's easier to find Itzel or 3C Ren because she'll be sending you an email as well. She knows where to find us. I have one question coming in from Cindy. Does anyone want to help study for the passive house exam? If anybody is on the call that
I
wants
still
to
reference my books. Still got them right here on my
I didn't
desktop.
pre-screen. Sorry, Cindy. Let's talk. Any other last questions? All right. With that, I'll hand it back to Itzel to close us out. Thanks everyone for joining us today for Higher Performance Building.
Yeah, thank you, everyone. Just wanted to thank everyone again one more time. Looking forward to seeing everyone soon. So yeah, have a good rest of your day. You could reach us at 3CREN, info.3cren.org, or just visit our website. Thank you so much.
Thanks, everyone.
Thanks, everyone.
Bye, everyone.